Have you ever found yourself in that all too familiar bind trying to set up a new development environment,
Oh, yeah.
only to fall headfirst into like a swamp of conflicting dependencies or just an endless maze of configuration steps?
Mm-hmm. I've definitely been there.
That feeling of dread when a new project lands and you just know you're in for hours, maybe days of setup headaches.
Yeah, it's not fun.
Well, today, we're taking a deep dive into a tool specifically designed to banish those very frustrations.
Vagrant.
And our mission for this deep dive really is to unpack how Vagrant standardizes development workflows. We want to look at how it turns these really complex setups into something you can basically conjure with just a single command.
A single command, wow.
Yeah. And how it lets you mimic production environments right there on your laptop, which saves, countless hours and gets rid of those classic, it worked on my machine arguments.
Right, the finger pointing. And as always, our insights are grounded in solid research. We're drawing heavily from a comprehensive guide, provagrant.pdf.
Specifically, it's foundational chapters that introduce, configure, and delve into the more advanced uses of Vagrant. Think of it as our shortcut, kind of, to understanding the true power behind this tool.
Yeah, it's a great resource. By the end of this deep dive, you won't just know what Vagrant is, you'll hopefully have a crystal clear picture of why it's become such an indispensable part of the modern developer's toolkit, for individuals and for teams.
Okay.
You'll understand how it doesn't just manage, but really tackles the information overload that comes with managing lots of different software projects.
Okay, so let's set the scene. Let's cast our minds back to maybe the not-so-good old days of traditional development environments.
You're right.
Imagine for a moment you're building a web application. You've got your client-side code running in your browser, maybe Firefox on your Windows laptop, but the server side, that needs a completely different setup. Maybe Apache running on Linux somewhere.
Yeah, totally different OS, different hardware even. It's that classic client-server model, right? The source actually has a figure 1-1, showing exactly that these two distinct machines talking over a network.
Right, and that's where the friction starts for developers, isn't it?
Absolutely, because as a developer, your daily grind involves running and accessing both sides, the client and the server, at the same time.
Right.
And traditionally, that meant, well, manually configuring these complex server environments, either right on your own machine, which gets messy fast,
Oh, yeah.
or on some remote server. And this manual way, it's not just slow, it's like an error magnet. Leads to inconsistencies, makes reliable development a real battle.
It gets so much worse when you're juggling multiple projects, right?
Yeah.
This is where you hear about dependency hell.
Exactly. Dependency hell. Picture this. Project A, maybe it needs PHP 5.3. That's what it was built for.
Okay.
But then Project B, the shiny new one, absolutely requires PHP 5.5. Suddenly, both projects are trying to use the same stuff installed on your main computer compilers, interpreters, libraries.
Right, they're fighting over the system resources.
Yeah. And you get version clashes, weird bugs that are almost impossible to track down, and just a messy, unstable setup. Switching between projects becomes a total nightmare. You spend more time fixing the environment than actually coding.
Been there. It's incredibly frustrating.
And the chaos doesn't stop at just software versions. It goes deeper into the actual procedures. The commands you need to run to start or stop the services for each project, they're usually different.
Right, like starting the database for one project is different from another.
Totally. So you have to remember all these different command sequences. It adds this huge cognitive load just remembering operational details instead of focusing on the code.
Yeah.
And of course, it's just more chances for mistakes and wasted time.
Okay, so that's a pretty bleak picture of the traditional way. So the million-dollar question then is, how does Vagrant swoop in and, fix all this? What's its secret sauce?
Well, Vagrant's most fundamental and honestly game-changing feature is what we call its one-command magic.
Okay.
The core idea is super simple. Create a complete, fully configured development environment with one single command. Vagrant up.
Just Vagrant up.
Just Vagrant up. And this isn't just a shortcut, it's a huge shift. That one command boots your virtual machine, or maybe even multiple VMs if your app needs it.
Right.
And then it automatically sets up everything, RAM size, shared folders between your computer and the VM, all the networking rules. It just handles it.
That sounds incredibly powerful. And what's really amazing, and maybe one of its strongest points, is that this single command It works no matter what virtualization tool you're using underneath, right?
Exactly. It doesn't care if you prefer VirtualBox or VMware or maybe Hyper-V. It just works.
Wow.
And it's also completely agnostic to the application's language or framework. Ruby on Rails, Python Django, PHP Symfony, doesn't matter. The experience is the same. And it works across different guest operating systems too, Linux, FreeBSD, even Windows. Vagrant essentially provides this simple, uniform command line interface that standardizes your entire workflow when you're using VMs. It hides all those complex, platform-specific details that used to cause so much pain.
So it kind of creates a consistent layer on top of everything.
Precisely. And that leads directly to what we can call the black box concept for developers.
Our black box, yeah.
Yeah, Vagrant shifts the responsibility for setting up and maintaining the dev environment. Instead of every single developer struggling with config files and weird commands,
Right.
that responsibility moves to a central point, maybe a sysadmin or a DevOps person. So for the average developer, the server-side stuff running inside that virtual machine, it just becomes a black box.
Okay, I see. So they don't need to know the internals.
Exactly. All they really need to know are maybe two commands. Del Vagrant up to turn it on, and Vagrant halt to turn it off. That's it. It massively reduces the mental effort, cuts down errors, and lets developers focus on, actually writing code.
Okay, that makes a lot of sense. To really see how powerful this is, maybe we should look at some concrete examples. The source material, it walks us through running a simple app called Songs for Kids, right?
Yeah.
Built with different frameworks.
Yeah, exactly. Those examples are perfect because they show Vagrant's flexibility and how it simplifies really different kinds of web setups.
All right, let's start with the first one, Project 1, the AngularJS version.
Right. So Songs for Kids with AngularJS. It's a simple little app, just 3 web pages. The front end runs in your browser on your main OS.
Okay.
But the back end is served from inside a guest OS. In this case, it's Ubuntu 14.04 running a basic HTTP server.
And the setup.
Here's the beauty. To get this whole thing running, you just go into the project folder in your terminal and type Vagrant up. That's it. Vagrant handles booting the VM, setting up the server, everything.
Wow. And this consistency, it holds true for the other frameworks too, like Ruby on Rails, Django, Symfony.
Incredibly so. The core workflow is almost identical. For the Rails app, once Vagrant up finishes, you'd probably go to http.localhost.3000 in your browser.
Okay.
For the Symfony one, maybe it's http.127.0 time 1.8880, but the process is always the same. First, bucket clone to get the code, then Vagrant up. And Vagrant just sorts out all the complexities of booting the right VM, setting up the environment. Doesn't matter if it's Ruby, Python, or PHP underneath. It just handles it.
That's really impressive. That standardization is key.
Absolutely. And another huge benefit, something that really smooths out the development flow, is the automatic file sharing between your host machine and the guest VM.
Ah, right. The code isn't just copied, it's synced.
Exactly. It's available in both places, simultaneously and continuously. So your main machine, where you have your favorite editor.
Yeah, my IDE.
Right.
Yeah.
And the VM that's actually running the code, they're always perfectly in sync.
And the practical upshot of that is,
it's immediate and really impactful. Any change you make to a file on your host machine is instantly reflected inside the VM. So imagine you're editing that Songs for Kids HTML file. Maybe you change Baba, Black Sheep to ABC.
right.
The moment you hit save in your editor, you refresh the browser page being served by the VM, and boom, the change is there.
No manual copying or syncing needed.
None. No complex deployment steps to your local VM. It's just a seamless live update. It speeds up that whole edit, save, refresh cycle massively.
How does that work technically? Is it complicated to set up?
Surprisingly simple. By default, the directory where you run Vagrant up from your project directory is automatically mounted inside the guest OS at Vagrant.
Just automatically?
Yep, Vagrant. This deep integration just removes so much friction. Your code is always exactly where the VM needs it to be.
Okay, so putting this all together, isolation, easy setup, file syncing. What does this mean for productivity, especially with multiple projects?
Right, that's where it really shines. You can actually run multiple completely separate projects at the same time, and they won't interfere with each other at all.
Seriously, like the PHP 5.3 and 5.5 example.
Exactly. The source examples show you can easily have your host OS plus, say, 4 different guest VMs running simultaneously. That's effectively 5 operating systems on one machine, each serving a different app, all coexisting peacefully.
Wow. So that completely solves the dependency hell problem we talked about.
Totally eradicates it. Each project runs in its own little bubble, its own isolated environment. They don't clash with each other. They don't mess with your host system. If one needs PHP 5.3 and another needs 5.5, they each get exactly what they need in their own VM. No more conflicts.
That's huge. And you mentioned mimicking production. How does that fit in?
Yeah, that's another crucial benefit. Each of these isolated environments can be configured to closely mirror your actual production server setup.
So fewer surprises when you deploy.
Precisely. It drastically reduces those, well, it worked on my machine problems. Each guest VM gets its own resources, like specific network ports, maybe 8800 for one app, 8000 for another, 3000, 8880. And these ports are carefully set up so they're only reachable from your host machine, not from the wider network.
So it's contained, secure.
Exactly. A contained, secure, and predictable development environment that looks a lot like where your code will eventually run.
Okay, that makes sense. It's not just about ease of setup. It's about consistency and reliability, too.
Definitely. Now, it's also really helpful to understand that a VM managed by Vagrant isn't just, on or off.
Right.
It can actually exist in several different states, and
Yeah.
each state has implications for how it uses your computer's resources, RAM, CPU, and what's happening on your hard drive. Understanding these states is pretty key to managing things effectively.
Okay, so what are these states? Let's start with the obvious one, running.
Right. Running is just that the guest OS is fully up and operational, using your host's CPU and RAM. By default, Vagrant usually starts it in headless mode.
Headless, meaning no graphical window.
Exactly. No GUI popping up. You can check its status easily using Vagrant status in your project directory. It'll say something like default running, VirtualBox.
Okay.
And in this state, your hard drive has both the reusable VM template, the source calls this directory B, and the unique project-specific VM instance, directory C, where all your project's changes live.
Got it. What's next? How do you turn it off?
That's the power-off state. You get there with Vagrant Halt.
Vagrant halt.
Yep. This gracefully shuts down the guest OS, stops all its processes cleanly. Importantly, any files you created or changed inside the VM, they're preserved.
So your work isn't lost.
Not at all. When you boot it back up, your files are still there. In this state, the VM only takes up hard drive space. It gives back all the RAM and CPU it was using.
No.
If you look in the VirtualBox main window, it'll clearly say powered off.
Okay, powered off. What else?
Then there's the saved state.
Yeah.
You trigger this with Vagrant Suspend.
Defend, like putting your laptop to sleep.
Exactly like that, but for the whole VM. It literally freezes the guest OS in time. Everything running processes, open files, the entire contents of its RAM gets saved to disk into that directory C.
And the benefits.
Super quick restarts. When you run a Vagrant Up or Vagrant Resume, it pops back to life exactly where you left off almost instantly.
Nice. Any downsides?
It can use more disk space in that directory C because it has to dump all the RAM contents to a file. VirtualBox calls this state saved.
Yes. Are there any other states? Maybe error states?
Yeah, there's the aborted state. This one usually happens unexpectedly.
Oh.
Two common ways. Either your host machine goes to sleep while the VM is running, or you interrupt a Vagrant Up halfway through, maybe by hitting Control+C.
Huh? Yeah.
When that happens, the VM is left in an inconsistent state. It's not properly off, not properly saved. The VM files are still there on your disk, but you can't really use it via Vagrant commands. VirtualBox will just show it as aborted, not ideal.
Right. Sounds like something to avoid if possible.
Yeah.
And the last state?
That's simply the not created state. This is just the starting point for any new Vagrant project. It means no VM instance exists yet for that project. It's the blank slate before you run Vagrant Up for the first time.
Okay, that covers the life cycle. Now, you mentioned running Vagrant Up for the first time is different. Can you walk us through what happens behind the scenes? It seems like magic, but I guess it's not.
Haha, not quite magic, but it is a pretty clever multi-stage process, even though it looks like one command. The source breaks it down into three main stages the very first time you run it for a particular box.
All right, stage I.
Stage I is all about getting the foundation, downloading and installing the box. Vagrant reaches out and downloads the base box file. Think of this like a template OS image. For example, Sinatra v1.0.box might be around 700 MB.
Okay, downloads the box. Then what?
Then it installed this box as a reusable VM template. It usually puts it in a system-wide directory, like .vagrant.d boxes. The key here is reusable. Many different projects can use the same template. You'll see messages like adding box, downloading a non-successfully added box.
Got it. Stage 2.
Stage 2, importing the base box. Vagrant takes that template it just installed and imports it specifically for your current project. This creates a new project-specific VM instance directory, often under VirtualBox VMs.
Ah, so this is the unique copy for my project.
Exactly. And it's usually much bigger than the original box file, maybe 2.2 gigabyte for that Sinatra example. This instance is meant to be managed only by vagrant commands created by up, removed by destroy. It keeps things clean.
Makes sense. And the final step, stage 3.
Stage 3, booting the system. This is where it all comes alive. Vagrant starts the guest OS. While it's booting, it sets up all the critical stuff from your Vagrant file.
Like networking in folders.
Precisely.
Yeah.
It sets up networking, like forwarding port 4567 on the guest to 4567 on your host. It matches MTA addresses for networking, configures those vital shared directories like Vagrant inside the VM pointing to your project folder, and it handles SSH access, even replacing insecure default keys with new secure ones. You'll see output like importing base box, booting VM, and finally, the magic words, machine booted and ready.
Right. So that first run can take a while then, especially the download.
Oh, yeah, absolutely. That first Vagrant up can be pretty time-consuming. Minutes, maybe even an hour or more, depending on your internet speed and your computer's hardware. There's really no way around that initial setup time.
It's the cost of getting that perfect environment.
Exactly. But the good news is, once it's set up, if you later halt or suspend the VM the next time you run Vagrant up, it's way faster. Because the VM isn't using RAM or CPU when it's stopped or suspended, just disk space. So resuming is quick.
Okay, great. Now that we know the states in the boot process, let's quickly run through the essential commands for managing these VMs day to day.
Sure. First up, Vagrant status. This is your quick check. It tells you the state of the Vagrant machine in your current directory.
And if you run it outside a project?
It's helpful. It'll prompt you to initialize one, or it might suggest using Vagrant global status.
Ah, Vagrant global status. What does that do?
That one's super useful. It lists all the guest VMs Vagrant has started anywhere on your system, no matter which directory you're in. Shows their ID, name, provider, like VirtualBox, and their current state. It's like your mission control for Vagrant VMs.
Nice. Then the main one? Vagrant up.
Yep, the workhorse boots the VM. It's smart enough to do the right thing based on the current state, does the full 3-stage setup on the first run, or just quickly resumes from halted or suspended states.
And to shut it down gracefully.
Vagrant halt. Clean shutdown, preserves your files inside the VM, stops using RAM and CPU.
And the freeze option.
Vagrant suspends, saves the exact state, including RAM, to disk, allows for a super fast resume later.
What about getting rid of a VM completely?
For a clean slate, Vagrant destroy. This stops the VM and permanently removes the project-specific instance files, that directory C.
Does it remove the original box template too?
No, importantly, it does not remove the template directory B, so the base box is still installed and ready for other projects. Destroy is just for that specific project's instance.
Okay, and one more. Vagrant reload.
Right. Vagrant reload. You use this when you've changed your Vagrant file configuration, like added a new port forward or changed a shared folder setting. It basically runs Vagrant, halt, then Vagrant up to apply those changes to the running VM.
Got it. And it's worth repeating that up and destroy aren't opposites in terms of disk usage, right?
Sure.
Destroy is much more drastic.
Exactly. Destroy wipes the instance clean. Up just brings it to life, using whatever state it finds suspended, halted, or needing a full build from the box.
Okay, great overview of managing the VMs. Let's pivot now to the real power, customization, through the Vagrant file. This is the blueprint, right?
Absolutely. The Vagrant file is where the magic happens. It's a Ruby file, but you don't need to be a Ruby expert. It lets you define and tweak almost everything about your VM. Its behavior, its resources, it's where you design your virtual world.
So what kind of things can we control? Especially thinking about VirtualBox, since that's common.
Right. Inside a config.vm.provider VirtualBox block, you get specific controls. You can give your VM a nice name that shows up in the VirtualBox manager, like vname equals my dev VM.
Okay.
And crucially, you can choose if it runs headless or with a GUI using v.equals_true. That GUI option is super handy sometimes for debugging, or if the guest OS has a desktop you need to interact with.
What about resources, RAM and CPU?
Yep, you control that too. vMemory 40.6 sets it to 4 GB of RAM, for example. The source guide gives some good advice here. Balance the VM's needs with your host machine. If you have 8 GB total, maybe give the host 5 GB and the guest 3 GB to avoid slowdowns from disk swapping.
Makes sense. And CPUs.
You can suggest a number of CPUs, and VirtualBox is smart enough not to let you assign more than your physical machine actually has.
Can you get even more low level?
You bet. Vagrant lets you use v.customize to pass commands directly to VirtualBox's management tool. For example, v.customize modify vm.id cper execution cap 50 would limit the VM's CPU usage to 50%.
Huh. Why would you limit the CPU?
Good question. Maybe you have a really CPU-intensive process running in the VM, like a build, but you still need your host machine to be responsive for other things. It gives you fine-grained control.
Interesting. Okay, what about settings that apply more generally, not just VirtualBox?
Sure. You can set the guest OS's hostname directly. config.vm.hostname, my app server. This is great for clarity, especially if you have multiple VMs talking to each other.
Makes sense. Anything else useful?
Yeah, a neat little usability feature is config.vm.post.message. You can set a custom message that prints out right after Vagrant Up finishes successfully.
Like what?
Like, hey, your app is ready at http.myappb.local.808u. Just gives the developer immediate feedback on where to go. Small thing, big help.
I like that. What about timeouts? Sometimes VMs take a while to boot.
Yep, Vagrant has default timeouts, 300 seconds for booting, 60 seconds for a graceful halt. But if your VM setup is particularly slow, maybe with lots of provisioning, you can increase these with config.vm.boot timeout and config.vm.graceful halt timeout. Prevents those annoying timed out while waiting for the machine to boot errors.
Good tip.
Okay.
Okay, let's talk SSH. How does Vagrant handle connecting securely? There were some security points earlier.
Right, security is important here. Often, public Vagrant boxes come with a default Vagrant user with sudo rights, and it uses a well-known password, Vagrant, and a standard insecure public SSH key.
That sounds bad.
It is. If left unchanged, it's a known vulnerability. But Vagrant is smart about this.
How so?
On the very first Vagrant Up, it detects that insecure key and automatically replaces it with a brand new, unique secure key pair just for that VM instance.
Ah, okay, so it fixes it automatically.
Usually, yes. It significantly hardens the security. Now, if you're creating your own boxes for distribution, you might have your own key management, so you can actually disable this automatic replacement with config.ssi.insert key. It's false.
Okay, and Vagrant mainly uses keys, not passwords, for SSH.
Primarily, yes. SSH supports both username, password, and key-based authentication. Vagrant leans heavily on the more secure key-based method. That's why Vagrant SSH usually just works without asking for a password.
Got it. Is there anything for graphical apps over SSH?
Yep. If you need to run graphical Linux apps inside the VM but see them on your host machine, you can enable X11 forwarding with config.ssh.forward.11 equals true. It tunnels the display over the SSH connection. Pretty neat.
Very cool. Okay, back to the Vagrant file. How do we actually tell it which box to use?
That's the fundamental config.vm.box setting. You specify the box name here, like ubuntrusty32. This tells Vagrant what base image to build upon.
And where does Vagrant find ubuntrusty32?
Good question. It can look it up on HashiCorp's Atlas service. That's atlas.hashicorp.com. Atlas acts like a directory and points Vagrant to the actual download URL.
So it's like a central repository.
Kind of, yeah. But you also have other options. You can give it a direct URL to a .box file anywhere on the web. Or, if you've already downloaded and installed a box, you can just use its local name, like my custom Ubuntu box. Lots of flexibility.
What if I download using a URL? Does it get a weird name?
It might, yeah. If you just use config.vm.box equals HTTP, Vagrant might name the installed box after that long URL. To give it a cleaner name, you use both config.vm.box equals my clean name and config.vm.boxurl equals HTTP. That tells Vagrant, download from this URL, but call it my clean name.
Ah, okay, that's much better for organizing. What about verifying the download, making sure it's the right file?
Excellent point. For extra security, you can specify a checksum. You use config.vm.boxdownload checksum with the hash value and config.vm.boxdownload checksum type like SHA-256.
And Vagrant checks it?
Yep. After downloading the box file, it calculates the hash and compares it to the one you provided. If they don't match, it errors out. Gives you confidence the box hasn't been tampered with or corrupted.
That's really important for security. Okay, we've configured the VM itself. Now, how do we connect to it? Let's talk networking.
Right. Communication is key. Getting your host machine to talk to the guest VM, maybe letting the VM talk to the outside world. Vagrant offers several ways to set this up.
What's the simplest option?
Probably forwarded ports. You set it up like a config.vm.network.forwarded port, guest 80, host 8080.
Okay, so port 80 inside the VM maps to port 8080 on my machine.
Exactly. So if you go to http.localhost.808080 in your host browser, the request gets forwarded to port 80 inside the VM where your web server is listening.
Seems easy enough. What are the pros and cons?
Pro, super easy to set up, great for simple single VM projects. Con, Host ports like 8080 can easily clash if you run multiple Vagrant projects at once. You run out of good port numbers fast.
Right.
And another big limitation. These forwarded ports are only reachable from your host machine. Other computers on your network can't see them. Vagrant does try to help with conflicts, though. It can autocorrect colliding host ports, usually picking one in the 2200-2250 range.
Okay, so what's a more robust option for multiple VMs or avoiding port clashes?
That's where private networks come in. You configure this to create a sort of hidden network just between your host machine and your guest VMs.
I need to set that up.
You can assign a static IP address like config.vm.network private network, bill IP 10.270.040. Now your VM has a stable internal IP address that only your host can see.
And the benefits of this approach?
Several. You don't need to configure forwarding for every single port the VM exposes. You can use standard ports, like 80 for web, inside every single VM without conflicts. And crucially, multiple VMs on the same private network can talk directly to each other.
Like a web server VM talking to a database VM.
Precisely, without exposing either to your main network. So why use over-forwarded ports? Because it mimics production setups more closely with internal IPs, and it makes managing complex multi-VM apps way easier.
Can it assign IPs automatically?
Yep, you can use DHCP too. Config.vm.network private network type DHCP. VirtualBox will then act as a DHCP server on that private network and hand out IPs automatically, usually something like 172.28.128.3. Useful if you don't need fixed addresses.
Okay, private networks sound powerful. Is there an option to make the VM visible on my main network?
Yes, that's the third main type, public networks. You configure this with config.vm.network, public network.
And what does that do?
It essentially makes your VM act like another physical machine on your local network. It gets an IP address directly from your actual network router's DHCP server.
And so my colleagues could potentially access services running on my VM.
Exactly. It becomes a full peer on the network. You can often specify which of your host's network interfaces to bridge to, like bridge and 1 airport, so Vagrant doesn't have to ask you during boot. You can also assign a static IP from your public network range if you need to, like IP 192.168.0.17. Running fizconfig inside the guest will show you the IP it got from your LAN.
Wow, okay, so lots of networking flexibility. Now, tied into this is file sharing, right? We touched on the default Vagrant share. Are there other options?
Yeah, the file syncing is fundamental. That default Vagrant share uses VirtualBox's built-in shared folder mechanism. As we mentioned, it works, but the source guide points out it's often the least efficient, maybe around 10 millibays.
Which can be slow for big projects.
Definitely. So for better performance, especially on Mac and Linux hosts, NFS, Network File System, is a popular choice.
NFS?
Yeah. It offers significantly better read-write speeds for syncing files back and forth. It might need a little bit of setup on your host machine first, but the performance gain, especially with lots of small files like node modules, can be huge.
Okay, what else?
There's also rsync. This uses the rsync command line tool.
Oh, rsync is great for efficient syncing.
Exactly. It's good at incremental updates. You need rsync installed on both the host and the guest. The source even mentions you can get rsync.exe for Windows hosts.
So it's cross-platform.
Potentially, yes.
Yeah.
And then specifically for Windows hosts, there's SMB, Server Message Block Shared Folders. This is designed to be a more performant alternative to the default VirtualBox shares on Windows, also offering bidirectional sync.
So the takeaway here is, choose your sync method wisely based on your host OS and performance needs.
Absolutely. That default share is easy, but if you're feeling lag, especially with large projects or lots of file I/O, exploring NFS or AirSync or SMB is a key optimization. It can make a real difference to your day-to-day experience.
Okay, great. Let's shift gears to automation. Provisioning. What exactly is that?
Provisioning is basically the process of automatically installing and configuring software inside the guest OS when you run Vagrant up.
So instead of manually installing stuff.
Exactly. Instead of SSNin and running apt-get install or yum install yourself or setting up config files by hand, provisioning scripts do it all for you automatically. It ensures every developer gets an identical, fully set up environment without any manual steps.
That sounds amazing for consistency. Eliminates all that manual setup.
Completely. No more logging in and running a checklist of commands. The provisioners handle installing dependencies, configuring services, maybe cloning repos. It guarantees consistency and kills those works on my machine issues dead.
Is there a catch? It sounds too good to be true.
There's a trade-off, especially initially. Provisioning can make that very first Vagrant up quite slow.
Ah, because it's actually installing everything.
Precisely. Downloading packages, compiling code, setting things up from scratch inside the VM takes time. There's really no way around that initial slowness if you need software installed. It's the price of automation.
But once it's done, it's done.
Mostly, yes. And if you change your provisioning script later, you don't have to destroy and recreate the whole VM. You can just run varg or vagrant provision on an already running VM to apply the changes.
Okay, vagrant provision. Handy. What kinds of provisioners does Vagrant support?
It supports quite a few, from simple to complex.
What's the simplest?
The shell provisioner. You can literally just put shell commands directly in your Vagrant file using inline.echo abc. Or, more commonly for anything non-trivial, point it to an external script file.path.setupwebserver.esh.
So you can just write standard shell scripts.
Yep. The source shows a good example. Using a shell script to install Jekyll, which needs Ruby and a JavaScript runtime. The script installs everything, then maybe runs Jekyll version just to confirm it worked. It fully automates setting up the server-side software.
Okay, shell scripts are good for basics. What about more complex setups?
For that, Vagrant integrates with proper configuration management CM tools like Puppet, Chef, and Ansible.
Ah, the big infrastructure as code tools.
Exactly. These let you define your server configuration in a much more structured, declarative way, rather than just a sequence of shell commands. The source shows examples of their output, installing packages like Node.js or RubyDev. They're built for managing complex systems reliably.
What's the advantage of using Puppet or Chef over just a shell script?
A key advantage is managing dependencies and execution order. For example, with Puppet, you can explicitly say, require this package to be installed after the package repository list is updated.
Ah, so ensuring things happen in the right order.
Critically important for complex setups, you need apt-get update to run before you try to install a package from a new repository, for instance. These CM tools make managing those dependencies robust and repeatable.
Makes sense. Now, managing all this configuration, especially the boxes themselves, version control seems important, right?
Absolutely critical, especially for teams. The source guide strongly recommends using Git not just for your application code, but also for the Vagrant file and any associated provisioning scripts or custom box building configurations.
Right.
Consistency and reproducibility, it ensures everyone on the team is working from the exact same version-controlled blueprint for their development environment.
What about .jitnor? What should we exclude?
Good question. Always, always ignore the .vagrant directory. This contains machine-specific runtime stuff state files, SSH keys unique to your instance. It should never be committed.
Okay, ignore .vagrant. Anything else?
Also ignore .box files. These are the large binary VM images themselves. They don't belong in your Git repo. They should be distributed separately, maybe via Atlas or an internal server.
Got it. And for managing box versions.
Using Git tags is a really good practice, especially if you're the one building and distributing boxes. Tagging releases like v0.10.0 or v1.2.3 helps everyone know exactly which version they're using and provides a clear history. The source actually shows appending these tags to box file names, too, for extra clarity.
Okay, that brings us nicely to building your own boxes. We've talked about using public boxes, but why would someone go to the trouble of creating one from scratch?
That's a really important question. If there are so many boxes available, why build your own? There are a few key reasons.
Like what? Security.
Security is a big one, yeah. When you build your own, you know exactly what's in it. You're not relying on a binary blob downloaded from somewhere potentially unknown. You control the entire process, minimizing security risks.
That makes sense. What else?
Customization and updates. You can create a base box that's perfectly tailored to your project's specific needs with all the right software and configurations already baked in. And crucially, you can ensure the VirtualBox guest editions inside the box match the version of VirtualBox on your host.
Ah, why is that important?
Mismatched guest editions are a common source of really frustrating problems, like shared folders suddenly not working. Building your own box lets you control that version alignment perfectly.
Okay, so how do you actually build these custom boxes?
There's a fantastic tool called Packer, also from HashiCorp, the makers of Vagrant.
Packer.
Yep. Packer is specifically designed to create identical machine images, including Vagrant boxes for multiple platforms, all from a single configuration file. It automates the entire build process.
How do you get started with Packer?
You download the Packer executable for your OS. And a really good tip is to set up the Packer cache eater environment variable.
Why? What does that do?
Packer often needs to download large OS installation ISO files, like an Ubuntu ISO, which might
Hmm.
be over 500 millibit. The cache directory lets Packer store these downloaded ISOs locally, so if you build multiple boxes based on the same OS, it doesn't have to download that huge ISO every single time. Saves a lot of time and bandwidth.
Smart. How do you tell Packer what to build?
Packer uses JSON files as templates. These templates define the entire recipe for building your box.
What's in a Packer JSON template?
Typically, there are four main sections, kind of reflecting the build order. First, variables for defining reusable settings, like the URL for the OS ISO.
Okay.
Second, builders. This is often the most complex part. It defines how to actually create the initial VM using VirtualBox from an ISO, for example. Packer can even run multiple builders in parallel, like building a VirtualBox image and a VMware image at the same time.
Wow, okay. What's next?
Third, provisioners. Just like Vagrant's provisioners, these run during the Packer build process to install software and customize the OS inside the VM before it gets packaged up. You can use shell scripts, Puppet, Chef, Ansible here too.
So you install software while building the box.
Exactly. And finally, post-processors. These run after the provisioning is done. They usually shut down the VM cleanly and then package it up into the final format, like a vagrant.box file. Packer even handles things like setting up unattended OS installations using answer files like precede.cfg for Debian Ubuntu.
That sounds powerful, but maybe complex to start from scratch. Is there a good starting point?
Absolutely. The Chef Bento project on GitHub is incredibly popular.
Chef Bento.
Yeah, maintained by Chef Software. It's a huge collection of pre-made, production-ready Packer templates for tons of different operating systems. Ubuntu, CentOS, Fedora, FreeBSD, you name it.
So you could just grab one of their templates.
Exactly. You clone their repo, find the template you want, like Ubuntu 14.04 i386.json, and then run Packer like build only VirtualBox ISO Ubuntu 14.04 i386.json. It uses their proven template to build a VirtualBox compatible box for you. It's a fantastic way to get started without reinventing the wheel.
That's a great tip. Okay, so we can build these custom boxes. Now let's talk about workflows for teams. You mentioned provisioning can be slow on the first run. How does that impact teams?
Right. If every single developer on your team runs those potentially long provisioning scripts every time they set up a project, well, the source calls that an anti-pattern.
Anti-pattern.
Yeah. Imagine a Vagrant file with complex shell and Puppet scripts to install a full Rails stack, maybe taking 30 minutes or more. If everyone does that repeatedly, it's a massive waste of time and resources across the team.
So what's the better way? The pro workflow.
Exactly. The pro workflow, as the source calls it, flips the model. Instead of developers provisioning from scratch, you have system engineers or a dedicated DevOps person responsible for building and distributing pre-baked, customized base boxes.
Boxes that already have all the software installed using Packer and provisioners.
Precisely. These boxes come with everything needed already inside. Developers then just use these pre-built binary boxes in their Vagrant file.
And the advantage is?
Speed and consistency. Developers can then Vagrant up, Vagrant halt, even Vagrant destroy and Vagrant up again without any penalty of that long initial provisioning time. Recreating the environment from a pre-baked box is super fast, often just seconds.
Wow.
This dramatically speeds up everything, onboarding new team members, debugging issues by starting fresh, running tests in clean environments. It's especially powerful for large teams and complex apps, a total game changer for efficiency.
So to implement this pro workflow, those configuration management tools, Puppet, Chef, Ansible, become really important for building the boxes right.
Absolutely crucial. If you're going to be building these pre-baked boxes, mastering one of these CM tools is highly recommended. They provide the automation and structure needed to do it reliably.
And within those tools, modularity is key.
Paramount. Whether it's Puppet modules, Chef cookbooks, or Ansible roles, understanding how to create and use reusable components is essential for managing complexity. The source actually suggests preferring the tool's built-in commands for managing these modules, like sudo puppet module install Puppet Labs Apache version 1.4.0.
Rather than using Git submodules. Why?
Using the tool's package management means the modules are treated as external dependencies, often stored in their own repositories, rather than being copied into every project. And specifying an exact version number, like 1.4.0 for the Apache module, guarantees predictability and avoids issues if a newer module version introduces breaking changes. It just requires you to manage the dependencies explicitly.
Okay, so you build these awesome pre-baked boxes. How do you share them easily with the team or the world?
That's where HashiCorp Atlas, now often referred to as Vagrant Cloud, really shines again. It started as just a box catalog, but it's evolved into a much broader platform.
For more than just hosting boxes.
Yeah, you can use it to build boxes with Packer integrated, deploy applications, and critically share your Vagrant environments easily.
How do you publish a box there?
It's pretty straightforward. You log in, create a new box entry, e.g. your app base, define a version like 1.0.0, add a provider, e.g. VirtualBox, and give it the URL where the actual .box file is hosted. Then you release it.
And then developers just use config that vm.box or app base.
Exactly. Vagrant handles finding it on Atlas Vagrant Cloud and downloading it, even if the actual file is hosted somewhere else. It provides that nice, stable, easy-to-remember name.
What about sharing a running environment?
Atlas Vagrant Cloud also supports Vagrant Share. This is amazing. It lets you share your live, currently running Vagrant VM with someone else over the internet via a temporary public URL.
Seriously? So someone could see my running web app?
Yep. Like http://random-words1234.vagrantshare.com. You can even share SSH access, Vagrant Connect, /random random words like 1234, and password protect the key. The coolest part. The person you're sharing with doesn't even need Vagrant installed locally. They just use Vagrant Connect. Great for remote debugging or collaboration.
That sounds incredibly useful.
Yeah.
Are there any other tools or plugins in the Vagrant ecosystem worth mentioning?
Definitely. The plugin system extends Vagrant in really helpful ways.
Like what?
One almost essential plugin is Vagrant VB Guest.
What does that do?
Remember the VirtualBox guest editions mismatch problem? This plugin automatically checks if the guest editions inside your VM match the VirtualBox version on your host. If they don't, it tries to update them automatically during Vagrant Up. It solves a lot of common headaches, especially with shared folders.
Oh, that sounds vital. Any others?
Vagrant Host Updater is really convenient. It automatically adds entries to your host machine's hosts file at hosts on Linux, Mac, somewhere else on Windows.
Why would you want that?
So you can access your VMs using the nice host names you defined in the Vagrant file, like http://my-server.local, instead of having to remember their IP addresses. Just makes life easier when you have multiple VMs.
Nice. One more.
For people using Chef for provisioning, Vagrant Omnibus is helpful. It automatically installs the right Chef client packages, the Omnibus installer, inside the VM, making sure Chef is ready to run your cookbooks.
Okay. Lots of ways to enhance the experience. Wow, that really was a whirlwind deep dive into Vagrant. We started with those familiar pains of traditional setups, dependency hell, manual configuration nightmares.
Right, it worked on my machine syndrome.
Exactly. Then we saw how Vagrant tackles that with its standardized one-command approach using Vagrant Up, and we explored the whole life cycle of those virtual machines running, halted, suspended.
And we pulled back the curtain on the Vagrant file, showing how you can configure pretty much everything: RAM, CPUs, those complex networking options like forwarded ports, private networks, public networks, and of course the power of provisioning for automating all that software setup.
Yeah, whether using simple shell scripts or full-blown tools like Puppet or Chef. And then we got into the really advanced stuff, building your own custom boxes with Packer.
Which is key for that pro workflow, getting away from provisioning everything from scratch every time.
Right, and leveraging Atlas or Vagrant Cloud for distributing those boxes, and even using Vagrant Share for live collaboration. It's a really comprehensive ecosystem.
It really is. So as we wrap up, maybe a final question for you, the listener, to think about. How might standardizing your development environments like this truly impact your team, your efficiency, your security, maybe even just reducing frustration?
Yeah. Could embracing these pre-baked version-controlled VMs be the secret weapon for smoother project onboarding, fewer deployment headaches, and really transforming how your team builds software?
It's definitely something worth considering. The potential benefits in saved time and reduced errors are huge.
We absolutely encourage you to explore more. Check out the official Vagrant documentation. It's excellent. And definitely take a look at that Chef Bento project on GitHub we mentioned. Get your hands dirty. Try building an optimized environment.
You might be really surprised at how much smoother your development process becomes.
Absolutely. You might just save yourself a lot of time and maybe a few headaches too.